Next, we will take a look at bagging and boosting methods. The bagging and boosting are the most popular algorithms when it comes to machine learning, when it comes to supervised machine learning algorithm. So compared to bagging, the boosting has gained a lot of popularity. We'll discuss boosting, followed by this section. We'll start with understanding what is bagging, first of all. So, okay, bagging is also called as a bootstrap aggregation. It's a type of ensemble learning method. So, what do you mean by ensemble method? So we need to pronunciate that way. Okay, we need to pronunciate as ensemble. It is a type of ensemble learning method. It looks for different ensemble learners by varying the training. Instead of creating a single tree, and based on a single tree, if I make a decision, it will not be, it could be whatever the decision I make it based on a single tree, right? For example, can I buy a car? Let's say I want to buy a car, I constructed a tree. So this is the cost, so and so cost, and this is the model, right? So I constructed a tree. So my model says only one decision tree. If I use that, it says, you can buy this car. Yes. Okay. And other, so that's what it says. My model predicted yes. Can I rely on this single model? The simple analogy, let's say you want to buy a car. So this is the first time you are buying this car, okay? Because you recently got promoted and your salary, you got a very good salary hike, okay? And you decide to buy a car now, okay? But this is the first time since you are buying the car first time, you want to be very cautious, okay? Because you are investing big money. So in that time, what you do is you go for the review in the internet. You do the review, and first thing what you do is you will ask your relatives, right? So you call your friend, close friend, ask him, so or ask her, which car is good, which brand is good. He says, okay, go for some brand name, okay. But if you get the feedback from one person, will you go by him? Will you go by his word? He says, so go for the Mahindra XUV. Will you consider his opinion? No, right? You will ask more than one people. You will ask your 10 friends. Of the 10 friends, you will do some kind of voting. So of the 10, majority of them they suggested go for Maruti Alto. It gives a lot of mileage. But two people they suggested some cars, right? But majority of them they suggested. So similarly, when it comes to the bagging, it constructs multiple trees. Okay, it constructs multiple trees, and then it aggregates the values from all the trees. In the case of regression problems, as I said, you can solve both the regression as well as the classification problem using bagging as well as boosting also. Okay, so even bagging and boosting falls under decision tree. So the idea of ensembling is group of trees, or forest. That's why they call it a random forest. It builds multiple trees. Each tree, may produce a different class level, right? It gives you the predicted class level. But of the majority, right? So majority of the trees, based on the majority of the trees voting, the final tree right decides. So what output should I give? Okay, this is what called as ensembling. It builds multiple trees. It looks for different ensemble learners by varying training. So what is the idea of this one? The building, the using the bagging. The objective of the bagging is reduce the variance of the decision tree. Reduce the variance of the decision tree. So we discussed about bias and variance. Okay, so in the case of bagging method, the objective is reduce the variance. Supposing you wanted to reduce the bias, then you can go for boosting. Okay, so if you want to reduce the variance, then you can go for bagging method. But even there are a lot of techniques are available. Okay, even the case of boosting, right? We can do we can reduce, we'll try to reduce the variance also. We can improve the, yeah, we will try to reduce the variance also, even the boosting. Okay. But in general, bagging is, the objective of bagging is to reduce the variance of the decision tree. That's why it constructs multiple trees. Okay. The bagging is also known as bootstrap aggregation. So what do you mean by bootstrap aggregation? Sampling. What it does is, it samples the data. It randomly samples the data from your training data set with replacement. Okay. Supposing you have 500 records are there in your data set, or let's say in your training data set, you have 500 records are there, right? So of the 500 records, let's, let's say you construct 10 trees. Okay. By default, 10 trees are created in the case of random forest in sklearn. Okay. This you want to, 10 different samples will be created. 10 different samples will be, 10 different samples are randomly selected from this data set. Okay. So for each tree, you have different samples, but there will be some kind of overlap. That is what sampling with replacement. Okay, I just a simple example. So let's say, I have something called 1, 2, 3, 4. This is my population data. Okay, if you do a sample, so 1, 2, this is sample 1. And in the case of sample 2, without replacement, if I say without replacement, you can do sample, n number of samples. So how many samples you can draw from this population? 2, 3, and S3 is 3, 4. Okay, can you do 4, 1? You cannot, right? Because already you have drawn here without replacement. But in the case of bootstrap aggregation with replacement, you can draw sample with replacement. 1, 2, you can do 1, 1 also. And you can do 2, 1. Okay. So that is what sampling with replacement, which is nothing but bootstrap. Which is nothing but bootstrap. Okay. So for each sample, for 10 trees, right, it draws 10 different samples with replacement. For example, you have tree 1 and tree 2, up to 10 trees needs to be constructed. But tree 1, you have selected values 2, 3, 4. And T2, there will be some kind of overlap. So 4, 8, 10. Okay, fourth record, 8th record, 10th record, and second record, third record, fourth record. So it does this sampling with replacement, which is called as bootstrap. Okay, that is what called as bagging. So in the case of bagging, it does the bootstrap sampling with aggregation. It goes by multiple trees. Okay, so multiple trees output, and then it does the aggregation. That's why it is called a bootstrap aggregation. It's a type of ensemble learning method because it is not relying on a single tree. It relying on the multiple trees, more than one tree. It looks for different ensemble learners by varying the training. It considers homogeneous weakliness and learns them independently from each other in parallel. This is another advantage of bagging. So in the case of bagging, each tree can be, all the trees can be constructed in parallel. So important point which you need to note down is it is used to reduce the variance of the decision tree. Okay, since you are using multiple tree, the variance is less because in the case of classification, you go by the majority vote. In the case of regression, you go by the average of all the tree. Hence, the variance is less here. This is what bagging is equivalent to bootstrap aggregation. So it considers multiple trees. And look here, you have this tree predicted the class level. Yes, this, so of these 5 trees, the three trees predicted the class label as yes. 2 tree predicted the class label as no. And if you see here for each tree, it randomly sample the data with replacement. So 138, 10, 15. Here also 138 is there. This is what sampling with replacement. There will be the sampling with replacement is called your bootstrap, and then it goes by the it aggregates this one, aggregates all the trees thing. It is not going literally by a single tree. It takes into account of all the trees output, majority of the trees output. So here the S is the majority. Okay. It is basically a voting based system. What does bagging, when does bagging means? When a regression method, when you find any overfitting, right? In that kind of situation, you can go for the bagging. Sorry. So random forest falls under the ensembling machine learning method. Okay, not only random forest, we have other algorithms like gradient boosted machine, ADA boost, and XGBoost. All these algorithms, right, falls under ensembling method. Okay, but in the case of boosting, boosting is also ensembling method. So in the bagging, okay, in the case of bagging is also ensembling method, but in the case of bagging, it goes by the bootstrap sampling. Okay, and then it does the aggregation, voting, as well as it goes by the average in the case of regression. The same principle is applicable in the case of random forest. Already explained about the bagging thing, right? The same thing is applicable here also. Random forest is a ensembling machine learning method. It can be used to perform both regression and classification tasks. Sorry. Like I discussed at the outset of today's session, right? So you don't have to do too much of data pre-processing. Majority of things it takes care, missing values. You don't have to do imputation. Even if you have outlier, it is not sensitive outlier. It gives us the feature selection. That is also another important feature of random forest. We have used RFE, recursive feature elimination, to find out the highly predictive features that have higher predictive power using RFE. Random forest also gives us the important features, the features that have higher predictive power. Okay, it gives us that. Okay, the same principle here. It creates multiple subsets from the training data set. So these are the steps involved in the case of random forest. Multiple subsets from the training data set with replacement. This is my data set. If I want to construct 10 trees, up to 10 trees, create multiple, first step is it creates multiple subsets. So sample 1, sample 2, up to sample 10 with the replacement. Okay, and then next it will grow the decision tree like T1, T2 up to T10 for every sample, as opposed to a single tree. Each tree has its own sample, but there will be an overlap of these sample values between one tree to another tree. In classification problem, the voting will be performed for every predicted result, like I've shown here. For example, in T1, T2, T3, T4, 4 trees. I think I already put the diagram. Yeah, this is the one. Okay. In classification problem, the voting will be performed for every predicted result. So 1, 2, the majority voting. So majority voting is done for the predicted class yes. Hence, the final output will be yes. For example, if I want to approve a loan to Mukilan, it builds 5 trees, and then for each tree it uses the bootstrap sampling, and then each tree predicts the class label, and also for each tree, importantly, it uses different set of features. So what are the columns it uses here? It will not be using the same column here. Number of features, the features also differs from one tree to another tree. Okay, and each tree produces a class label, and it goes by the majority voting. So, okay, of all the predicted class, which class has a majority in it? So yes, right. Finally, it says Mukilan, yes, he is eligible for loan, something like that. The first step is create the multiple subsets from the training data set with replacement. Okay, and next it will grow the decision tree for every sample. Okay, and then in classification, it will go by the voting. Okay, in the case of regression, it goes by the average. For example, you forget about yes or no here. Let's say here you are predicting the housing price. It says for a specific size of the house and number of bedrooms and age of the house. For these three independent variables, you created a random forest. Behind the scene, it created multiple trees. And then this tree predicted the housing price for that given specification as 800K. And here it has given, 802K. Okay. And here it says 787K, something like that. Okay. And here 792 here. Let's say 850K. It takes the average of all the nodes values. So 1, 2, 3, 4, 5 divided, so add all these values divided by 5. That is what the estimated housing price. Right? It takes the average of outputs by different trees in the case of regression. In the case of classification, it simply goes by the majority voting. It's as simple. That is what random forest, it's a very simple concept, but we don't have to create the trees manually. It builds the tree behind the scene on our behalf, but we have a tunable parameter, n underscore estimators, using which you can specify how many number of trees to be created. And again, so too many trees also will take, will cause a higher training time. Okay, and lesser tree also leads to some prediction accuracy related issues. So we need to find out the optimal number of trees. Okay, so for that we have something called cross validation. Okay, we have something called cross validation. Grid search CV. We have some grid search CVs available. Hyperparameter tuning. We'll discuss it as part of tomorrow's session about that. Okay, so the advantages of the random forest is it solves both regression as well as the classification task. It handles missing values and maintains accuracy for missing data. And with this, we can prevent the overfitting. And importantly, it handles large data set with high dimensionality. And the another important point is feature selection. It helps us to do the feature selection. The disadvantage is good job at classification. It is not good for regression. The same thing is applicable for boosting also. Any classification problem, if you want to solve it, you can use bagging and boosting. But if you try to solve regression problem, it is not that accurate. Okay. But XGBoost somehow okay, but still it is not much good. Okay, before wrapping, it's already 8 o'clock. Before we wrapping up, what is the difference between bagging and boosting? The random forest model uses bagging. Okay, boosting I'm yet to cover. After completing this, if I talk, it will make sense. Because in between, I was talking boosting, but it's not enough. Any of that is, we'll discuss in tomorrow's session. It's already 8 o'clock. We need a lot of time, right? So fine. All right, so we will circle back. Okay, until 8:30, right? Good. We have some more time. I thought we started by 6 p.m. We do one thing. I stop.